Okay, working with geometric series again, the question is use summation notation to express the sum. So we know it's a geometric series because they told us that. The summation symbol is the sigma, which is this symbol here. What I need to do is put an equation here, and then for the index I need to tell n equals 1 to whatever number will give me this last number in this expression. So let's use the one of these formulas, and we're going to use the first one because we need to know this particular term. So let's look at this formula and find out what pieces of information do we know to use that. Well, do we know a sub 1? Sure, a sub 1 is 8. A sub 1 stands for the first term. Do I know the r? Well, I can find it. 8 times r equals 16. R equals 2. Let's test it. 8 times 2, 16. 16 times 2, 32. So it seems like times 2 would work all the way along. The next term would be 64, and so on. Now, rather than just keep multiplying by 2, I'm going to develop a formula. And that formula is going to go here. So, r equals 2. What else do I know? I don't know the n. Ooh, I do know a sub n. The term I want here is 2048. So 2048. So let's put that into the formula and see what we can solve. So 2048 equals 8 times 2 to the n minus 1. All right, first step, what do you think we ought to do? Yeah, divide by 8. So 2048 divided by 8, 256 equals 2 to the n minus 1. Now at this point I need to solve for n. Well, if n is in the exponent, I need to use logs to solve for n. So let's take the log of both sides. Log 256 equals log 2 to the n minus 1. Beauty of this is now I can take that exponent, put it in front, and I will be able to solve for n. So write it again. Log 256 equals n minus 1 times log 2. At this point, let's divide both sides by log 2. If you want to distribute first and solve that way, you can, but make sure you multiply that by both of those parts. It's easier to divide by log 2 first, so we're going to do divide by log 2. Divide by log 2. All right. And again, take out your trusty little calculator and divide both sides by log 2. And you do that, and you get 8. So 8 equals n minus 1. So what does n equal? N equals 9. So n equals 9, that means that's the 9th term. So now, can I really write the equation? A general equation, a sub n. This should work to find any term. This is the first term, 8 times r to the n minus 1. Whoops, r is 2. 2 to the n minus 1. Now, let's test that. Remember we figured out 64 is the 4th term. So a sub 4 would equal 8 times 2 to the 4 minus 1. Well, that's 8 times 2 to the 3rd. What's 2 to the 3rd? 2 times 2 is 4 times 2 is 8. 8 times 8? 64. Ooh, it checks. So our equation for a sub n is correct. So that's what goes here. 8 times 2 to the n minus 1. One other technical difficulty. I need to do n equals 1 should give me the first term. And what did I say? That we had 9 terms? N equals 9 gives me that. I'm going to test it just to make sure. So 8 times 2 to the 9 minus 1. 8 times 2 to the 8th. So 2 to the 8th, I'm going to use my trusty old calculator for that one. 2 to the 8th is 256. 256 times 8 times 8. 2048. Oh yeah, 2048. It checks. So, I don't know if you could see all of my writing there or not, but there you go. That's how to find the equation and write using summation notation. Point of interest. If 1 doesn't work when you're checking to get your first term, sometimes try 0, sometimes 0 works. And go from there. Good luck.